can 9 coins be arranged in a line? There's 3 dimes, 4 quarters, and 2 loonies. If they're all distinguishable, they're all unique, it would just be 9 factorial. That's it. Okay? Or if you want to do the fundamental counting principle with the slots, no problem at all. What if all similar coins look identical? So if they were distinguishable, I'm talking about 3 dimes. One that was made in 1990, one was made in 2010, right? Like anything in there that makes them different, right away makes them unique. But what if they were all exactly the same, like all dimes looked exactly the same, you can't tell them apart? How would this change? You would go 9 factorial, and then you would just divide out the 3 dimes, the 4 quarters, and the 2 loonies, because you don't want to count you moving them around, right? You do not want to count that because they're exactly the same. I'm not going to give you the answers. I will post the answer key later. 9 bag, so a bag has 6 marbles, 3, 2, and 1. How many ways can all 6 without replacing the marbles after each draw? How many ways can you replace them? So you can do fundamental counting principle. Okay, so there's 6. So that'll be 6, 5, 4, 3, 2, 1. You're not replacing it back in the bag, so you're almost assuming you have 6 for the first, 5, 4, 3, 2, 1. So that'd be 6 factorial, right? Can I just stop there? No, there's something wrong with that right now. They're marbles, right? These are all identical. So that'd be divided by 3 factorial, divided by 2 factorial. Do I need to divide the 1 factorial? I don't need to, but you could if you wanted to. It's not going to affect anything. So that would be 720 divided by, this is 6 times 2, that's divided by 12. All right. What's the answer to that? 60 ways. I'm going to leave this one later. Chapter 5. We'll do this one later in chapter 5. I know some of you are eager to go about that one, but I don't want to do it right now. Okay, next. True or false test has 8 questions. How many different permutations of answers are possible if 5 answers are true and 3 answers are false? Okay, so that's for, so in this case, what I want you to think of is 8 factorial. There's 8 possible answers, and 5 of them are true, so that'll be 5 of them are true, so that'd be 5 factorial, and 3 answers are false, that'd be 3 factorial. So in that case, I would just want you to go 5 times 3 factorial like that. And because all the truths, you can't really flip-flop them, right? Like if you move them around, all the truths are the same, and all the false questions are the same. I'm just going to say this one is it doesn't ask you for how many possible ways can you answer on a multiple choice where you've got like 4 or more options. This is just true and false for every single one. Next, the word rearrange. N is equal to 9. N is equal to 9. And you've got 3 R's. And you've got 2 A's, and you've got 2 E's. Okay, so these are identical. You got to make sure you get that right. So for A, it's just 9 factorial over 3 factorial, 2 factorial, 2 factorial. Okay, that's how you. Even if there are no conditions, you still need to divide out the repeats. I will do B here. Must start with a G. Only have one option. How much is left then? 8 factorial is left. Because it's, if you did the slot method, you would go 8, 7, 6, all the way to 1, right? But not so fast. That would be 1 times 8 factorial. You still need to divide out the 3, 2, and 2. You still need to do that, no matter what. C, it must start with an R. It is a repeat. Not yet. Just got to wait a little longer. So this is a repeat. So you've got your, how many R's do you have? 3, right? I only put 1 in the front because I don't want to count them all as separate. How much are you left with, folks? 1, 2, 3, 4, 5, 6, 7, 8. You still have 8 slots to fill. So please don't start with a 7 or anything. There's just 1. So it's 8, 7, 6, 5, 4, 3, 2, 1. Like that. So this would be 1 times 8 factorial. What are we going to divide it by? We only have 2 R's left because 1 is fixed. So we used to have 3, we would divide by 3 factorial, but in this case it's fixed, so it's 2 factorial. And then you're left with 2 A's and 2 E's. I'll make a note, only 2 R's left. Okay, so that's how you would solve that question. D, all the A's have to be grouped together. They have to stay together. How many A's do we have? We've got 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Imagine it's one of these. The A's are together. You go 2 factorial, and then zoom out. There's 1, 2, 3, 4, 5, 6, 7, 8. So that's your 8 factorial. Not so fast, right, Mrs. Erickson? Not so fast. 2 factorial, 8 factorial. What are we going to divide this by? We're still going to divide it by the repeats. This is not, they're not fixed. The 2 factorial, the 2 A's just have to be together, but they can move anywhere you want. So you still have to divide by 3 factorial, 2 factorial, 2 factorial, no matter what. Let's highlight the fact that for all of these, we kept on dividing the repeats for all of them. E, we're going to run out of time here, right? E is simply A's together, so there are 3. The R's, there's 3 R's and 2 A's. And then you still go, where is E here? You still go times 6 factorial, because there's 6. If you count the zooming out, there's 6. You still divide by 3 factorial, 2 factorial, 2 factorial. You still do that. There it is one more time. And F, let's do this before we go. Must start with an A or an R. So AR. 1, 2, 3, 4, 5, 6, 7, 8 left. Watch this. You go 2. It's 2 cases. What will this next number be? Will it be 7? 9 minus 2 is 7. It'll be 8, 7, 6, 5, 4, 3, 2, 1. So it'll be 2 times 8 factorial. Write this down before you go. Over 3 factorial. 1 factorial, because the A is up front, and 2 factorial. Okay, before you go,